Right. So next topic is holography. So normally these holographic images look like a 3D image and they carry entire information about the object. So in general, whatever conventional photographs record the information in 2 dimensions, right? So when you need information about the 3rd dimension also, and you need to record the phase of the object. Phase of the object also need to be recorded. So here in holography, I will be recording information on a 2-dimensional photographic plate itself, but it carries entire information about the object. So any wave can be represented as a phase amplitude format, in a phase amplitude format. So this is the amplitude of the wave, this is the phase information. So this holographic image records both intensity is what? Square of amplitude. So it records both intensity as well as phase also. So that is a primary advantage with holographic images. So they carry entire information about the object. So I am considering an object and I am taking a light source here. So when light falls on the object and reflects back, we will be able to see the object, or the object information will be recorded. So in addition to the light rays received from the object, I am taking a reference wave also reflecting from a mirror. So I am taking 3 light rays, whatever. So I am taking light rays reflecting from an object and light rays reflecting from a mirror. So this is my reference wave. So this is psi r. So this is psi r and this is psi o, object ray. So these two interfere and will be recorded on a photographic plate. Okay. So both object wave and reference wave interfere, and the interference information is recorded on the photographic plate. Okay, so now what is the result of interference? So when you mix 2 waves and see the resultant, it is given by so here the amplitudes will add up during interference. So intensity is square of amplitude. Amplitudes add up. So what is the result? So it is A naught e power I phi, there is no time information, I phi naught, and AR e power I phi r square. So you have to take modulus amplitude. So all imaginary terms will be complex conjugated and then multiplied. So you have to take psi star psi. It is e power minus I phi naught plus AR e power minus I phi r. So when you are taking modulus square, you have to take complex conjugate and then multiply. So what is the result? It is A naught square. So here also you will have a complex number. So it is since it is a real number, it is okay. Anything is valid. So it is a naught square plus ar square plus a naught ar e power I phi naught minus phi r plus ar a naught e power I phi r minus phi naught. ar a naught e power I phi r minus phi naught. These are the four terms you get. So it is I naught plus IR. So resultant amplitude is I naught plus IR plus A naught AR e power I phi naught minus phi r plus e power minus I phi naught minus phi r. So it is I naught plus IR plus A naught AR two cos phi naught minus phi r. E power I theta is cos theta plus I sin theta, and this is cos theta minus I sin theta. So you will be left with 2 cosine theta. So on the photographic plate we have information about intensity of the object wave, intensity of reference wave, and phase information of object wave and reference wave. So everything will be recorded on the photographic plate. So this carries information about the intensity of object, intensity of reference wave, and the phase information. Of object and reference wave. So now I try to reconstruct the wave. So for that purpose I am considering a reconstruction wave with same parameters as the reference wave. Same phase as the reference wave. Like here. So reconstruction wave has same features as the reference wave. So I am using same light source. So now I am multiplying this reconstruction wave or generating an interference pattern with this intensity information. Just I am projecting this reference wave onto the photographic plate. So the photographic plate carries only this information. So I am multiplying this sign. So this is the result you will get when the reference wave falls on the photographic plate. So what do you get? This is A naught square AR e power I phi r So I'm multiplying at this level. So then AR square AR e power alpha R then I'm multiplying e power plus I phi r, so this gets cancelled. We'll be left with a naught ar square e power I phi naught plus ar a naught ar e power minus I phi naught e power plus 2I phi naught. So I'll have AR e power I phi r with an additional two terms, a naught square plus AR square. So I'm drawing that image. So I'm taking the photographic plate and I am inserting that reference wave. I am inserting that reference wave on the photographic plate. This is size C. What happens? So these waves will travel unaltered on one way, and at some point they will generate the image of the object, and at another point they will generate the reflected image of the object. So there are three possibilities. One term is same as the incident wave. Reconstruction wave remains same with some amplitude modifications. AR e phi r is just multiplied by a naught square plus ar square. So this is a naught square plus ar square multiplied by psi c. Only an amplitude variation without any change in the incident wave parameters. I mean, its intensity reduces a little bit because it is passing through a material. So that is one wave. Another is same as object wave, a naught e power I phi naught, ar square multiplied by psi naught. AR square multiplied by psi naught. So the same as the object wave without any modifications. Another is mirror image of the object wave, e power minus I phi naught. So these are the three waves you will get when you incident the reconstruction wave on the holographic wave. One is the direct reconstruction wave with small variation in amplitude. Another is object wave with some modification in amplitude. Another is mirror image of the object wave. Phase is inverted. So here the phase is e power plus I phi naught, here it is minus I phi naught. So which one is real and which one is virtual? So here the light waves incidenting on the plate and reflecting back. So this is a real image, and this is virtual. So virtual image looks exactly same as the original object, but it is virtual. So it is formed exactly in the same location as the object when it was recorded. So it is on one side of the photographic plate. You'll see that exactly in the same location as the object when it was placed while recording. So you will see a virtual image of the original object in the original location. So that is the advantage with holography. So entire information about the object is recorded on a two-dimensional plane.